Welcome back again to this edition of tutorial. We are still on the simultaneous equation. At this time, this is the question we would like to consider. It says that 2x plus py equal 5 being the first equation, and the second equation is 4x plus 5y equals 0. Our simultaneous equations where P and Q are constants, and where P and Q are constants, full stop. And then the solution to this pair of simultaneous equation is S equal Q while Y equal minus 1. Find the values of P and Q. This is a quick one. We are not going to spend too much time on it. It's so straightforward. Starting by saying that solution I pick up the first equation, which is 2x minus py equal 5. We've been given some valuable informations, that is S equal Q and Y equal minus 1. Put in where X equal Q as Y equal minus 1. Putting this back into this equation 1. Call this one equation 1. It become 2q minus p, y is minus 1. So if I write minus 1 here, equal 5. This one is no different from 2q. Minus p multiplied to minus 1 is plus p. S equal to, that should be the first equation, the first format. And this one, probably let us call it equation 3. And then, honestly, we've tried everything, but there's no significant progress. Then what we have to do, we have to try the second equation to see whether we have a significant progress. Of course, we have a significant progress because the second equation being 4x plus 5y, it doesn't have any unknown constant. With that one, surely we have a significant progress. Then, picking it from equation 2, we will have 4x plus 5y equals 0. But we are told that s equals to q, so 4q plus 5y is minus 1 equals 0. So we have 4q minus 5 will be equal to 0. Yeah, sorry about that. I think in copying the question, there was a mistake that was done. There should be here at this point. In copying, there was a mistake in the equation. There was a mistake in the equation 2. The question says that 5y plus q. Yeah, sorry for that one. So this one will be let's read the whole equation again. The whole question again. 2x plus py equal 5 is the equation 1. And then we have the second equation before x plus 5y plus k equals to 0. They are simultaneous equations where p and q are constant. The solution to this pair of simultaneous equation is x equals to q, y equals to minus 1. Find the values of p and q. We started by picking the first equation being the 2x minus py equals to 5, and we substituted the values of the given values of x and y, where x equals to q, y equals to minus 1. We came to the third equation and we saw that there's no significant progress in it. And since there's no significant progress in it, we pick out the second equation, which we trust that of course we will have a significant progress, because at least we know the values of x, and we also know the values of x and y. That will make us find the value of q. So we brought that equation here, 4x plus 5y plus q equals to 0. Then wherever we see y, we put minus 1 there. Wherever we see s, we put q there. Whose result is 4q minus 5 plus minus 5 plus q. So we will have here 4q plus q equal 5. 5q equal 5, which leads to q equal to 1. Therefore, the requested value, that find the values of p and q, we have found the value of q being the first one. Now let's continue. We are going to find the value of p. To find the value of p, it is also not a big deal. You know that in equation 3, we can use equation 3 to find the value of p as we know the q. So from equation 3, we have from equation 3, we have 2q plus b equal 5, where q has been found to be 1. So we have 2 times 1 plus b equal 5, which indicates that p equal 5 minus 2 equal 3. Therefore, p equals to 3. Hence, the values of p is equal to 3 and q equals to 1. But we should remember that q x is equals to q, which indicates that x is equals to 1. We also know that, okay, let's put it here, x equal to q here. X equals to q equals to 1. So if we are trying to make reversion, having got to know the values of p and q, and we want to insert into the equation 1 and 2, we will find out that the original simultaneous equation should have been 2x minus p, which is 3, y equal 5. And the second one is 4x plus 5y plus q. We can bring the q, it is plus, we can bring it to the other side to make minus 1. Q was, to make minus 1. So this should be the simultaneous equations whose solution is unique. Whose solution is unique as s equals to 1 and y equals to -1. Meaning that the solution of this simultaneous equation is equal to s equal to 1, y equals to -1. And this will be the point of intersection where these two lines will meet. And how to sketch it, it is something that we've already dealt with in the previous tutorials. They are not a big deal. Probably you can take your time, to see how we sketch it, but I don't think that because of the propensity of the time, let me see whether we can, but in the meantime, take your time to copy everything that we've done here, as I'll be standing at the other side of the board to give you a clear board, to give you a clear view of the board so that you can copy everything. Take your time, copy everything, and then we'll come back again for the next question or for the continuation of the question. Take your time. Welcome back. This is another type of simultaneous equation. At this time, we can see that the first equation is an equation of a line, while the second equation is an equation of a curve, which is a rectangular hyperbola. The second equation is a curve of a rectangular hyperbola. I will show you how it is. But the first one is an equation of a line, and the second one is an equation of a curve, a rectangular hyperbola. Okay, if we have such a simultaneous equation of this one, it is still not a big deal. Why? Because it is two simultaneous equations in two variables of x and y. And by the way, it is not a big deal. Let us try to use substitution approach. Let's try. Later on, we'll try to use elimination approach as well. Okay. I'm going to pick up either one of the equation, whichever I pick up, it will be good enough. So solution. If I pick up let's say the first equation, which is x plus y equal 11. That one is not different from, x equal 11 minus y. And I'll call this one equation 3. And I'll say that putting equation 3 back into equation 3, equation 2. But be careful, we can only put the equation 3 back into equation 2, but not in equation 1, because equation 3 emanated from, or came from, or evolved from equation 1. So we cannot put that equation 3, which came from equation 1, back into equation 1. It is impossible. So what we can do is that we can rather the equation 3, which emanated from equation 1, we can only put it back into equation 2. So put it in equation 3 back into equation 2, which is that one. We can have x is 11 minus y. So this is the equation x, y equal 30. So we have x is 11 minus y multiplied to y equals to 30. Okay, then we'll try to continue in this session. We'll come back to this session to continue. So we'll have 11y minus y squared equal 30, which is no different from y squared, which is no different from 0 equal y squared minus 11 plus minus 11y, rather minus 11y plus 30. What we did was that to pick up the left-hand side term, shifted it to the right-hand side. So being negative here, the y square came to the right-hand side and became positive. Being positive here, the 11y came to the right-hand side and became negative. While the 30, which was at the right-hand side, still remained the same, unmovable. I mean, we didn't move it anyway. So it has resulted in a quadratic equation in y. Quadratic equation in y. Honestly, I believe that you know how to solve quadratic equation like this, which is y. This equation is not different from 0 equal y squared minus 11y plus 30 is very much identical to y minus 5y minus 6. So you can see that this specific equation gives us the two values of y, and they are it will be 0 equal y minus 5, y minus 6. So if you pick up only this one and equate it to 0, you have y minus 5 equals 0, and then you pick up only this one and equate it to 0, you have y minus 6 equals 0, which indicates that we have y equal 5 and y equal 6, which tells us that, in fact, the curve and the line will intersect at two different points. First, at the point where y equals to 5, and secondly, it will intersection will repeat at where y equals to 6. Now, we know the y values of the points of intersection. What about their respective x values? To find the respective values, you can choose either equation 1, 2, 3. But this one, relatively, being the smartest one to pick it up, we can pick up equation 3 and say that from equation 3, from equation 3, where to when y equals to 5, when y equals to 5, then it becomes s equal 11 minus 5, which implies is s equal 6. At the same time, when y equal 6, then we have x minus 11. S equal 11 minus s equal 11 minus 6, which implies is s equal 5. Yeah, s should be equal to 5. So we have s equals to 6 and s equals to 5. Very good. If you watch here, we saw that when s equals to 6, when s equals to 6, y equals to 5, x equals to 6, y equals to 5. And also, where y equals to 6, s equals to 5, s equals to 5. Y equals to 6. So these are the 2 points of intersections where the line and the curve will intersect. Now, let me show you something. I believe at this time I would like to, this is a peculiar question. I will have to sketch the graph. First, let us pick up the first equation, which is an equation of a line, which is x. I think you know that this is the point of intersection, so that's okay. X plus y equal 11. So y is equals to negative x plus 11, which is an equation of a line in the form y equal to mx plus c. This is a line. Comparatively, you can see that the gradient of this line m is minus 1, and the y-axis intercept c is equal to 11. So you can see that this is a line with a negative gradient of 1. So such line will be like y-axis, and this one is x-axis. A negative gradient, it will be something like this. So we find out that the y-axis intercept is this one, 11. But we can also find the x-axis intercept. On the x-axis, if you come here, you come to this equation, you can see that on the x-axis, this is the equation of the line, though this is the equation of the line. It is the same as this one. You can find the x-axis intercept either from this equation or from this equation, and this one will be more obvious, meaning that the line will cross the x-axis at the point where y goes to 0, or we say that on the x-axis intercept y equal to 0. When y equal to 0, then you can see that from this equation, this one, y will be equal to 0. We will left up with s equals to 11, which indicates that the line will cross the x-axis at 11 as well. So this one will also be 11, and this should be the origin. Now, Our next target is that we are going to try to sketch this curve. So at the moment, as the board is fully occupied, I would like to step at the other side for you to have a clear view of the board, so that you can copy everything, and then I'll wipe everything, and then we'll pick it up from where we left off. Take your time, copy everything, pause the video, and then pause the video and copy everything, and then we'll come back again to continue from here. I think before we'll go on to sketch the graph. I think there's also another possible way that we could have gone to have the same answer, and that is what I want us to consider now before we will move on. So, as you see on the board, from the second equation we have, which is this one, x, y equal 30, which indicates that x equal, which one? Which indicate that let's say y, which indicate that y equal 30 over x. Now we pick it, this will be equation 3. Putting equation 3 back into equation 1, we will have x is this one plus y, which is 30 over x equal 11. And then we will cross multiply, or we will multiply through by x. So you can see that we have x multiplied to x plus 30 equal 11 and 6. So we have x squared plus, or x squared, we are bringing this one to the left hand side, 11 minus 11 x plus 30 equals 0. This is also a quadratic equation in x, almost identical to the one that we previously solved. So with this quadratic equation in x, which is 11 x squared, which is x squared minus 11x plus 30 equals to 0. If we factorize, we have x minus 6, x minus 5 equals to 0. We have x equals to 6, and we have x equals to 5. And then if we want the respective y value, we can pick it from here or from there or from there. But it is expedient to choose the third one without tears. So we can choose the third one as y equal 30 over x, which indicates that where y equal 30 over, we pick up 6 first. Then we have y equal 30 over 6 equals to 5. Which imply y equal 5. Then second one, we have y equal 30 over x, where x equals to 5. Which implies is we have y equal 6. Which indicates that? Which indicates that as x equal to 6, we have y equal to 5. Good. And then as x equals to 5, we have y equal to 6. Exactly. The same as what we had by going by that way. Now, let us take the advantage. Previously, we sketched the first. Graph, which was the line. At this time, let us try to consider the second graph, which is the curve. This equation, x y equal to 30, can also be written as y equals to 30 over x, or sometimes we can say 30 multiplied to 1 over x. This equation is called a rectangular hyperbola. And the rectangular hyperbola is of the form of like this. So this equation, as you see there, this will be the sketch thereof. Now, we are going to sketch both the line and the curve on the same axis. That is our next target. So at this time, I would like you to take your time to copy from where we started, and then finish at this point. As you pause the video, and I'm going to stand at the other side, so that you can have the clear board. You know what I mean? You can copy everything as you see it. And then the next target is that we'll try to sketch the graph of both the line and the curve. Wow. Okay, now we are going to sketch the curve and the line. So y-axis, and this is x-axis, and let's say this is the origin. Now, in that earlier, we found out, but before that, let us be reasonable. The sketch of the curve, we say that it's a rectangular hyperbola. It should be something of the form this equation is the one with this color is the x, y equal 30. And then the other one, the line was, let's see, it's not beautiful. We should make it beautiful. This is rough sketch anyway. This is not the approximate curve, this is a rough one. This is not the exact curve, but these are the 2 points of intersections. And we had quoting from the previous one. Y we will call at some point, this is the y equals to 6, x will be equal to 5. So this is x equals to 5, y equals to 6. And this is x equals to 6, y equals to 5. This is the approximate. Yeah, then that should be the and this this one is the curve x, y equal 30, and this line is x plus y equal 11. So you can see that both the curve and the line, they intersect at 2 points. Where x equals to 5, y will be equals to 6. Where x equals to 6, y be equal to 5, being the solution of the simultaneous equation. The point of intersection, the points of intersection is the solution of the simultaneous equation. Now, at this time, then we'll bring this tutorial at this time to a close for the time being, and then we'll continue by considering another question in our next lesson. So now let me pray for you. The Lord Almighty God bless you. The Lord Almighty God make his face shine upon you and lift up his countenance upon you and give you peace. Whatever you do, may you prosper. I pray for wisdom and understanding for you, that whatever you do, you have the wisdom of God. God bless you. God bless you. I think this is 11, and this point is also 11. Have a lovely day. God bless you. Bye.